over to Ajay.
Yeah, cool. So I guess we'll get started. Let me just share my screen and then we can go from there. Okay. Can you guys see my screen or?
Yeah,
Okay, cool. So, hi guys, my name is AJ, and so this is our introduction to CADing. And so with this meeting, I kind of want to get you guys to understand what CADing is and how important it is to FIRST Robotics because yes, we can definitely build mechanisms just by putting parts together using a drawing board and stuff like that. But I think if you want to really push your team's abilities, then learning how to CAD is a great skill that the students learn, and not only students but mentors as well, and it really helps you grow. So just a little introduction. So I am the mechanical design mentor for Naki Robotics and Dawn Robotics. So these are two teams. One is in Toronto, Ontario, and the other is in London, Ontario. And so I'm going into my 10th year of FIRST. Technically, five of them are student years. I did 1 year as an FLL student and then four in FRC. And then I've been mentoring for 5 years now. And then I'm also a fifth year mechatronics student at Western University. And so that's kind of just a background of who I am. And so starting the presentation, why use CAD? And so the first bullet point is it helps you build better robots faster. And so one of the biggest premises with CAD is your ability to kind of design things and be able to change them in a very easy manner compared to just building stuff without designing. And so it lets you have more room to kind of experiment with things. The next point is it's a great visualization tool. And so we'll see in a couple of examples is you're really able to visualize how your robot is going to look before you build things, because I know many people have, us included, ran into issues where we design a mechanism but soon realize it conflicts with something else. And so being able to CAD robots is a great skill in order to help you understand how your robot is going to fit together and how everything will flow and be integrated. And so another step is if you want to start fabricating parts. So whether your team decides to use a CNC, either in-house or external uses, using mills and various other tools, even 3D printers now, which has become a very new thing that a lot of teams are starting to experiment with within FIRST. Learning how to CAD is really going to help your team grow exponentially in order to unlock these new skills. And overall, it's just a great skill for any engineer to have, whether you're in programming or in mechanical design or even electrical. One thing that I really preach to my students is no matter which strand you're technically in, learning around about all the other aspects are really going to help you. And yeah, so when it comes to CADing, there's two different levels of depth. So on the left here, we can see a very early prototype for Citrus Circuit, so 1678. And then on the right, we can see a finished product of 2910. So both are really high level teams. And so what we can take away is there's a very big range into how much CADing you're using when it comes to building your robots. So one thing that I think every team should be able to do is something on the left, where this is essentially just a box CAD where you're essentially just laying out a bunch of your pieces. So what we can see here on the right is you have your drive base kitted out, and then you can have a little intake mechanism to kind of see how that fits into your picture. They have their filter mechanism for their balls, and then they have it going up to their shooter. And so they can see how high their shooter is. And so now that they have this main structure of the robot, they need to figure out how they're going to climb that year. And so you can see how they have an entire tubed out section for how their climber will look. And so that's kind of where teams will probably start, depending on how much resources your team has to allocate towards designing robots. You could end up with something like 2910 later down the line. And so with this robot, you can see how it's fully detailed. They have everything from mechanical to electrical to all the sensors that they want to use. Everything is nicely fabricated. They have the parts that they want to powder coat. Um, Everything is just very well thought out. And so this is something that if your team has a lot of resources to dedicate to um, learning how to CAD and developing that, you can start to develop and fully flesh out the robots that you want to build, as well as it's a great kind of media point. You can see that they've rendered their image using SolidWorks. And so with this, they're able to quickly advertise this to various sponsors and stuff like that in order to really help bolster the image of the robots that they're designing. And so anyone have any questions regarding any questions regarding the level of depth for CAD? If not, we can move on. So one of the common questions is what software to use, whether it's SolidWorks, Onshape, Fusion, Inventor. There's a bunch of different options to use when it comes to CADing. And the two that I really recommend are Onshape and SolidWorks. Onshape is what we'll be focusing on today, and SolidWorks is another one that we get a lot of licenses for teams through First, which is a really helpful tool. And so basically the biggest difference between these are that SolidWorks is more tailored towards simulations, and Onshape is really good for online work. So SolidWorks is essentially an application that you need to download onto your computer. And when it comes to parts, it's very much the files are on that computer and you need an external source in order to move these files around. But you do get to be able to do some high quality detailed work. And the biggest thing is simulations. If you wanted to simulate the stresses and the strains that are applied to different parts, calculate how much inertia I guess, certain mechanisms will have. This is all really nice and easy to do in SolidWorks. But the biggest benefit to Onshape, which is especially prevalent to first teams nowadays, is that it's all online and it's very similar to a Google Drive fashion, where teams are easily able to share their part files between different members. So when it comes to, say, I'm a student and I'm working on the intake mechanism, I can share this file with a bunch of different other students that are also working on the intake file. And similar to Google Docs, people can be working on parts in the same at the same time. So in terms of a team atmosphere, Onshape really captures the ability to work really easily remotely and encourages a level of entry to students that isn't intimidating. And it's why a lot of teams are starting to pivot towards Onshape. And so as we go through the demo, you'll start to understand some of the benefits to Onshape and how easy it can really be. And so I think the three main topics we'll be aiming to cover today are geometric sketching and Crayola CAD. So Crayola CAD, if we go back quickly, is very similar to this left-hand image, where it's very much you place mechanisms to specific areas to kind of get a feel for how the robot is going to be built. And geometric sketching is something that I think every team should be able to do and should be pushing to do, because you'll see in this example with this year's game is you're able to take advantage of CADing software without having to do everything in 3D. We'll also then be able to create a new part that we want to design. And then we also want to build an assembly from this. So we'll try and get through as much as we can. And then we'll kind of go from there. So does anyone have any questions so far? Cool. I guess we'll continue. So so I guess the first step is getting to Onshape. Just Google Onshape and then you'll be able to come to this window. One of the biggest benefits to Onshape is it's free for students to get access to all this stuff. So they'll just go through this portal. which says create a student account. And then if they use their school email address, they'll get a bunch of the features for free. Um, with mentors, it depends because I do believe as an educator, you will be able to get a lot of these similar perks. How you go about signing up to that, we'll have to see. And so if you wanted to create an account, it's very simple. You'll have your student go through this and essentially fill this all up. And then once you've signed in, you'll come to this screen. And so this is essentially the Onshape dashboard. So if we quickly go through it, starting from the left-hand corner, we have the create function. And so this will allow us to import and design various parts, create new documents, files, folders, import a bunch of stuff. So that's kind of in that menu. And so we have this little dropdown called owned by me, and we can open up recently opened files. So if we look at this, we can see all the recent files that we've been working on. We can see created stuff by me. So the files that you as a team create yourself, and then you can also see the shared with me. And so when it comes to building with teams, the shared with me function is really great because it will allow a lot of different students to work through their own projects and collaborate together with these mechanisms. And then you also have labels, which is a nice ability to kind of organize your stuff. And so going back to this main page, so this is just a getting started page. And so we'll review some resources at the end, but one of the biggest things is if you see this, take a self-paced course. So for those of you who really want to get into learning Onshape, this is essentially a really good way. It's basically a course that you can take in order to learn Onshape. And so it teaches you a lot of the fundamentals that we'll be covering today, but you'll be able to go through this at your own pace. And I really recommend anyone trying to learn this to go through it. They have a couple of modules that you'll go through. And then another good one is the CAD for robotic competitions. And so this is specifically tailored to designing robots in CAD. And so we can kind of see some of the stuff that they're covering, drivetrain, custom components, collaboration for teams, manufacturing, and then communicating your design. So this is a lot of the stuff that you'll be tackling within a first build season. And so these are two of the links that I recommend checking out. And they'll be in the slide, which we can share later. So now that we have that covered, lastly, open, similar to your Google Drive, you'll have your latest viewed parts here. And so next we have folders. So you can have a folder system for all your parts, which is nice when it comes to organizing. And so we can take a look at this practice demo, for example. We see one mechanism. And so the way I kind of like to teach is through examples. And so if we open up this part, so a CAD can basically be broken down into two components. This is technically an overall assembly. So you can see this model. So this is modeled after Dropshot, which is 254's robot from 2016. The goal is to build the intake. So we kind of want to copy their intake and use it as a learning lesson for us to be able to design parts going forward. It's a very simple mechanism that I think as you go through will really teach you a lot of the basics. So here we can see that the mechanism is essentially 3 1x1 pieces of tubing with a roller down here for intaking their ball, because in Stronghold it was a 9-inch compressive ball. And then they have this back roller in order to cycle that into their shooter. And then they also have a gearbox down here. For our sake, if we go back to this mechanism, we won't have enough time to really go through all of this stuff. So I think we'll focus mainly on creating this frame piece. So these 1x1 pieces of extrusion, we'll create some gussets in order to rivet or connect this all together. And then we can also create a roller, and I'll show you, if you have time, how to import and get some parts. So yeah, before we start, are there any questions? So if we go back to Onshape, I'll start from the very beginning. So let's say we wanted to create this brand new. We'll go to open a folder, and then we'll say November 14th demo. So this is essentially a folder that will hold all of the files. And so the way that you can use Onshape is very particular to your own needs. So for example, if we go back to this file, you can see how this mechanism is technically going to be a subassembly. So what I personally like to do is um, you treat this mechanism as your subassembly, and down at the bottom here, you should be able to see the various parts that we're going to be building. And so these are your part windows. And so you can see each individual part that we've designed. And all together, we can combine these individual parts into an assembly. And so that's what this final product will look like. And so this you can treat as a subassembly. And so going back to our example, if we scroll up to the overall picture of the robot, one way that would be easy to organize this robot would be your drivetrain is one subassembly, your intake would be a second subassembly, their climbing mech would be a third, and then their shooter would be a fourth. And so if you were to break up your robot into that sense, you could have four different subassembly teams. And so they all collaborate, and you as a mentor would be able to look over all this collaboration and then help the students bring those four components together and then design an overall robot using each subsystem. Okay, so the first thing we'll do is we'll create a new document. And so this will be our intake subassembly. So when it comes to naming conventions, a lot of teams like to do various different things. For us, we mainly like to include the year that we're designing this part, the subassembly it belongs to, and then the part number. And so that part numbering system, 100 will essentially be the base of it. And then you increase. So 101 will be one channel, 102 will be the length channel, 103 can be a gusset. So it kind of follows that naming convention, but everyone can do parts differently. And so at the bottom here, we can see there's a part studio and an assembly tab. And so we'll essentially be designing individual part studios. And then we can take these parts into our assembly and we can import them and fix this all together. So before we start that, let's take a look at geometric sketching, which I mentioned before. So as a quick rundown, this may look very daunting to have a lot of these tabs open, and you may be wondering what all of this means. When it comes to designing parts, a lot of this stuff you probably won't use. There are core components, which we'll be covering today, which will very much help you in designing essentially any robot that you wanted to. A lot of this stuff is essentially stuff that you can learn on your own. And so we'll be mainly focusing on the core components. And so on the side, we have these are essentially collaboration tools in order to see different parts. So you can check the version history of parts. So you can see the edits that people are making. You can then create your own version. So think of this similar to GitHub in the sense that you can take people's version and then you can branch off from that, making your own changes and then comparing the two. You can make comments on certain parts. So if you're a mentor who's designing a part, right? If you have a student who's designing a part and you're a mentor, you can come into the file and then you can comment on certain areas. So for example, you can mention if a part like the intake is going to be in clearance for the shooter, for example, or if part A is too long. So it's a very helpful thing in order to help students, which is something that only you can do in Onshape. SolidWorks really lacks in the collaborative aspect, which is why a lot of teams have shifted over to Onshape. And so that kind of covers the main stuff from this column. On the top row, you can essentially see that we have a sketch, extrude, revolve, and all these different functions that we'll use. And so the way that I think of designing parts is you have a 2D part. So let's say I wanted to design something, I would essentially imagine it as a 2D sketch. And then I would think about how we can bring that into a 3D space. And so you have your three different faces on the sides here. And so when you're designing robots, you just want to keep in mind how things will orient together. And this orientation is more so to help you later down the line. For our case, we'll do everything on the front plane, but when you build more detailed robots, then you may want to keep this in mind a lot more. And so here we have our property manager. And so this is essentially going to tell us all the changes that we're going to make on this sketch. In this part, and then we'll be able to call back all this stuff. So the best way to start is to essentially go through it. And so the first thing we want to do is create a new sketch. And so it's asking you for your sketch plane. And so we're going to design on the front plane. And so this little cube in the corner will allow you to shift the orientation of the workspace itself. And so if we go to front, then we'll be able to look at the front view. You can also use on your mouse, you can click down the scroll wheel and you can drag the workspace left and right, up and down. And then if you use your right mouse click and hold it down, you'll be able to orient it as well. So to start with sketching, one thing I'll quickly show you is geometric sketching and the importance of using this in first. So let's say, for example, if we look at this year's past game, let's say we wanted to score the cone. So with the cone, probably explain. So this is a line tool. We can use the line tool to, as it says, create lines. And so with each line, we can click and draw in this workspace and kind of go through and click and drag where this is going to be. So we have a question. So how do you use the wiring custom feature? So I was wondering if you could elaborate on that point. Do you mean for electrical stuff, or do you mean a tool in Onshape? And so as we wait for that response, so essentially you can think of this as a drawing board. And so if you have a line, you can essentially draw this in any space. And so when we look at the first field for scoring a cone, we can think of the two poles that are sticking out. And so as you can see, these are blue, and this means you can shift it around and extend it. Basically, this means it's not defined. And so in order to define things, we need dimensions. And so if we go up here, we can see the dimensions tool. It looks like a ruler. And so by clicking the dimensions, we can click on the line itself, and then we can get a distance. And so this is in inches. And so we can assign a distance that this line will elongate to. So right now I can say it's a 1-inch line, and it will edit there. And then I can come back and double click in and adjust that to a 3-inch line. And then it kind of adjusts its reference. And so in terms of the first field, I believe roughly this was 1 foot. And then your your larger pole was 24 feet. And so now we can assign lengths to each line. But now the question is, how do we define this distance? And so we can go back in, we can click our dimension tool. And so from the origin, we can distance to this line. And then we can edit our distance here. And so let's say it is 24 and 40. So now that our sketch is black, it means that it's fully defined. So if I click any piece, I won't be able to move it because it's fully defined and it's constricted. And so this is essentially a sketch of the field. Hopefully you guys can visualize the poles that are standing there. And then we essentially, when it comes to geometric sketching, it really helps us understand the capabilities of a robot. So to kind of cover this very quickly, if we use this corner rectangle, so we have this rectangle feature. If we click that little arrow, we can get different types of rectangles. So for our need, we're going to use a corner rectangle, which essentially means that we're going to click on a point and it's going to be the corner, and we can drag out to essentially any point in space. And so if we dimension this to be 32 in length by roughly 6 inches in height, this is a rough estimate of the kitbot frame. And so what we want to do is, let's say we wanted to make, for example, a double jointed arm, and we wanted to place it in the center of our robot. So if we see this line here, this little square pops up, and then we can drag a line from there to indicate that it's the midpoint. And so we can have one arm here and one arm like this. And so this essentially is, if you think about it, this can essentially act as your arm. It's a double jointed arm, and say you were trying to place a cone onto this back layer. And so we can quickly dimension that line. And let's say we wanted to make it 35 inches. And then we also wanted to make this one 35 inches. The biggest benefit to be able to do this is you can quickly see if these measurements will be able to reach the point that you're trying to achieve. And so when it comes to first, this is a really handy skill when you're designing mechanisms at an initial phase. So if I wanted to design something like an intake, I'd be able to quickly model the game piece on the ground, compare it to our drivetrain's dimensions, and then see the length of the intake that I'm going to need, where I need to place the rollers, what type of sweep the intake will have when it goes from its resting position to its down position. And as you can see with this, we can change these different measurements. So let's say we wanted to make this arm as small as possible. If we reconstruct these to be 30 by 30, then we can see, will this be able to reach? And we can see it kind of is able to reach when it's fully extended. So one of the things that we can do is we can delete this constraint and we can move this piece closer. So I want to click on here. So this little corner piece, and we want to click this line. And so up here, we have different constraints. And so constraints are really helpful when it comes to sketching because you can assign things like the two parts are coincident to each other. If you have two circles, they can be within each other, which is concentric. You can have two parts that are parallel, tangent, it's vertical, horizontal. So when we design parts, we'll see this a lot more. And so for now, we just want to make these two coincident. And then we want to take our dimensioning tool again, and then we can dimension, let's say it's 10 inches from the front of the robot. And so now we can see that it's able to reach. And so this is essentially just a quick overview of geometric sketching. It's just a really handy tool that's allowing you, without having to design every single detail of every single part, you can kind of see if your logic will be able to achieve these things. So instead of having to build an entire mechanism and then realizing that the length was too short and you weren't able to reach your goal. This is just a really quick check that you can do in order to make sure that everything works properly. And so if no one has any questions regarding this part, then we can create our first part. And so if we go back to, I'll just open it in a new tab. And so we'll cross-reference this with the part that we want to design. So the first part that we want to design is the center piece of tubing. And so with this piece of tubing, we'll be able to design this from scratch and then use this as a 1x1 piece of tube. So if we look down here, so we can click on our part studio and then we can click rename and we can call this our geometric sketch. From there, we can insert a new tab and we want to create a new part studio. So this is essentially creating a new part for this subassembly. And so of similar nature, we can click sketch and we can choose our front plane. And then we can orientate ourselves in order to be on that front plane. And so on the top here, we can see you have your drawing tools, as I like to confer this section. You can draw lines, corner line rectangles and squares, circles, arcs, polygons of different sides, and then you can have some text if you wanted to. And so this is a lot of your drawing tools when it comes to designing. Then you have what I like to call features, the main ones being changing lines from a solid line to a construction line. So construction line is just a line that you're using for reference, and it doesn't really have any effect on the part. You can have fillets to kind of have edges. And so I think someone has a question.
Yeah, it's Peter.
Yep.
Just wondering, like I've noticed on some of the sites like AndyMark and things like that, that they actually have CAD files of the part, like if it is a 1x1 piece of aluminum. Can we just bring that in, or do we have to actually draw it physically, like what we're doing right now?
No, you can. That's a good point to mention. Hopefully, we'll have enough time to briefly cover that. But like you're
Okay,
saying,
cool.
you can be able to import parts instead. When it comes to something like a 1x1 piece of tubing, it's very easy to design in concept. So it's just a good practice for students to just build over time. Um, but you're right, when it comes to things like bearings and motors, then we definitely import them from somewhere like McMaster Car or AndyMark, and then we bring them into the studio and use them for our assemblies.
Thank you.
And so I believe there's a good comment that mentions part libraries. And so, yeah, part libraries is something that's available. Different teams have them as well. And so they have very basic parts that a lot of teams will use. So things like screws, so fasteners, tubing, bearings, wheels, stuff like that. They'll already have that combined into one folder. And so if you look around, you'll be able to find these and then tailor them towards your needs as a team. And so just to go through this quickly, so essentially we want to build.
Can I just add something there?
Yep.
This MKCAD product is something that I think another team has accepted responsibility for. It's a whole library of FRC parts, and they can be pulled in basically by selecting them off of a menu. The MKCAD thing simply needs to be installed on a standard on-shape setup. It just shows up as a button, and you can click on the button, drop down, you can find motors, gearboxes, motor and gearbox assemblies of different kinds. Really very, very handy. So I see us using that a lot in the coming year. We've never used it before, but certainly that's something we will be in the current year.
Yeah, thank you. I think that's the first time I've heard about it, but it sounds super interesting. I don't know if you have the link that you could provide to the other members. But yeah, that would sound really
Yeah,
cool.
I'll check and get back to you.
Okay, cool. So let's just assume that we wanted to design a piece of 1x1 tubing. So the first thing we're going to need is a rectangle. And so we can click this drop down and we want a center point rectangle. And so if I draw this rectangle, I can draw it in a space. But what happens if I want to put it at the origin? So the first thing I want to do is click on the center of here, and then the center, which is our origin. And then we want to click the coincident constraint, and then this will bring the two together. So the next thing is we need to define the length and then the width. So for a 1x1 piece of tubing, the length and the width are both 1. So we can create a dimension and specify this to be a 1 inch. So one things that I teach my students a lot is to use as many relations that you can, because relations, when it comes to changing parts later down the line, are much easier than dimensions because you'll have less to change. So for example, if I wanted to dimension both of these, so the length of this line, I could also do 1. So this is one way to get a 1x1 square on your sketch. The problem is if I wanted to change this to 2 inches, then I would also need to come back in and edit this. And so what we can do is we can click this top line and the side line, and we can find our equal constraint. And so as it says in the dropdown, it makes them of equal length. And so now we can see that's all black and it's fully defined. And so now if I change this to a 2-inch square, then it all moves together. And so depending on the purpose, we find that using constraints is a lot easier. And I recommend people to play around with them and find out what they like to use as a team. And so to make our tubing, we're going to, if I click on the center, we'll draw on the origin as well. And so this measures the outside 1x1 piece, and then we want to make our inner thickness. And so if we go back in dimension, we can dimension between these two lines, and let's assume that our thickness is 1/8. And so now all that's left is if we click our top and our side line again, we can make them equal, and then we can have our 1/8 piece of tubing. So now we have a 2D flat sketch, but we want to be able to translate this into 3D space. And so that's where these two functions come in. So your extrude and your revolve. So extrude is what you're going to be using majority of the time. And your revolve is when you're creating more circular parts. So something like a pulley or a gear or like a frisbee or something like that. Circular objects are more for revolve. And then extrude is basically where you're going to add material or take away material. So to our sketch, what we want to do, let's say we want to make a super wide intake that spans our entire front base of the drivetrain, which is 26 inches. We want to extrude this sketch out to 26 inches. So all we need to do now is click the extrude button. And so it's going to auto select this face. That's what's in this section here. We can delete this as well. And so we can highlight this. Then we can click on this if we wanted to select something else. And so you're going to have different options here. And so what we want to do is we want to use blind, and then we can specify the depth, which is how long we essentially want this piece. And so like we said, we want this to be 26. And so we can specify that to be 26 inches. If I change my view, yep, we can see how it's a lot longer now. And so if I play around with this length, you can see this is just a preview of what this part is going to be. This direction tab will also flip the direction if we want to. But for our sake, we'll mainly be using it as it is. And so We have an add function, which is adding more material to this. And we have remove, which is also removing parts. So we'll see that in a little bit of how we're going to use this. So what we want is a new solid, and we want to have it of 26 inches in depth. So now we can see that our sketch has turned into a 3D piece of tubing. And so our next step is to get this holing in order to match our gussets. So what we're going to do is we're going to sketch onto this top surface. And so we can orientate. And we have our line. And this line is going to represent the center between our two halves. And so we want essentially an equal hole pattern going throughout the middle. And so we can click this line, and we want to make it for construction, which is over here. And now this won't be within something. So if we were to cut from this material, this wouldn't be taken into consideration. It's mainly a guide for us. So let's say we want like this, a a 1/4 inch hole pattern every 1 inch. So what we can do is we can create a circle, and we can click it onto the line and then drag out. And this will allow us to create a circle on our sketch. Similarly, going to the dimension tool, we can click the circle and we can specify the diameter of the circle. So 0.25, if we zoom in, will give us a 1/4 inch circle. Next, in order to fully constrain this, because right now, if we drag this, it can move anywhere on this plane. And so what we want to be able to do is set a distance for it. So if we click dimension again, from the top, we can specify 0.5. And so this is a 0.5 from the edge. And so the question is, if you wanted to have an entire hole pattern, what's an easy way to do it? And so when it comes to sketching, we have this thing called a linear pattern. And this essentially repeats a certain thing over a linear period. And you can also do this in a circular pattern as well. And so to quickly demonstrate this, we've selected our linear pattern. And let's say we want to select our circle. This view pops up where we're able to identify which axis we want and how many. So in our, let's consider this the x-axis, we actually only want one of them. And in our y-axis, we should be able to fit 26. And then if we flip this, we can now have 26 holes, which may be hard to see right now. And so we can right click, and then we can see all the holes that we have. So now we can easily just cut out all of these holes without having to draw each individual hole. And so we have 26 holes that are spaced out 1 inch apart. And so we can easily change this to, if I only wanted 5 holes instead, we can see that we can easily edit that number. And so now we want to go back to our extrude tool. And so it's going to select this sketch that we were just working on. But instead of add this time, we want to click remove. And so we can choose a depth for how much we want to remove. But in our case, we want to go down to through all. And so through all will cut through the entire plane. And so if we click OK and go back to view our part, we can see that the hole has been cut throughout. And so that's kind of how we can make use of cutting out material. So hopefully that part demonstrates kind of some of the basic functionality when it comes to designing parts. And so quickly what we can do is I will show you how to import a part really quickly, and then an assembly as well. So if we open up our assembly tab, it's very different in terms of we have an insert function that allows us to insert different parts. And then we have a mate connector, and then various mates that we can apply to our parts in order to constrain them. So some being more specific, for example, a screw relation. So we can have that screw mate within parts, or we can just have simple revolute mates. So circular object within circular object, or just two parts that are against each other. So if we insert in our part studio. So we want part 1. And click this and click OK. And so this here is our origin. And so the first thing is we want to connect with our origin. So if we click the fasten mate, and so if we find, so this will be the center of our tubing. So we can click this, then we can click the same face on here. And so now if we try to drag this around, it does not move. And so now this is fixed at our origin. And so it's always good to have your first part fixed at the origin so that everything else will be able to build from that origin, which is handy for stuff later down the line when it comes to getting calculations. And so we can insert another part as such. And so we can click the fasten mate again. And so let's say I want to make this top face of this 1x1 piece of tubing to the bottom of this. So I've selected the top hole here. Now I need to orientate this so I can select the bottom hole here. And so as we can see here, they've become mated together in a sense where they are now touching. And so I can reorient the secondary axis. So I can spin this around however I like. So for our case, let's say something like this. And so this is how we can mate 2 parts together. And so when you imagine something like your intake, you'll be able to mate all these parts together, and then you can mate the gussets on top, and you can create this structure in the end. And so going back to here, let's insert a new part. So if we click, so if we go to something like McMaster car, and we search up a bearing, and let's just grab any ball bearing that we can find. So let's say we want this top one. We can click on this part number, and down here they have a 3D SolidWorks model. And so you can download this model, and then it will come as a step file. And so we can go back to our insert menu, and we can click import. So in my example, I have already downloaded a flanged bearing from the McMaster car website. So by clicking this and opening it, it will ask me if I want to import this document. And so I do want to import it. And so it's successfully imported. So now if we look down at our part studio, we can see that we have a new part, which is the bearing. And so like we were saying before, you don't need to entirely design every single part. You can simply import the parts that you need and mate them together. And so let's go back to this example. And let's say we wanted to make a new assembly. So we create an assembly. Since this has all the parts in it already, we can take this gusset, for example, and let's say we want to mate these 2 parts together. We can choose a revolute joint instead in order to grab the back of this piece and then mate it to the back of this piece as well. And so there we go. And so this is the revolute joint is much easier when it comes to mounting circular objects together like you saw there. And so what we can do now is we quickly insert this roller. Insert and open up our roller. We can quickly make a revolute joint between here and then this face here. And then we can flip the direction, click OK. And so hopefully you can see kind of how we ended up getting to this intake by essentially designing all these pieces of tubing. We can then design gussets in a similar manner where essentially we sketch. So something, for example, like this L, we would just design an L shape, and then we can make this all together. So I think that wraps up the time we have for this session. Hopefully that's a decent enough introduction. I do recommend taking your time and going through the Onshape CAD fundamentals, and then also the first robotics stuff. These two will really capture a lot of the basics foundational stuff that you'll need, that you and your team will need for building stuff during the build season. And so I guess to wrap up, I should be able to send Neil this slideshow, which will have all of the resources. So Symbotics has a really good SolidWorks series, the Solid Professors and other great resources. And then we have Ramp, which is a YouTube channel by 973. The 971 also has a CAD library, which you can use, and these Onshape libraries that we mentioned before. And then if you have any questions, you can feel free to email our team, and then we'll be able to get back to you if you need some help, not only with SolidWorks stuff, but if you have questions about programming and electrical, we'll feel free to help you out.
I've added a bunch of links in the chat for the FRC 3005 team resources. They're calling it onshapefrc.com. There's an excellent getting started thing. Provides access to how to install MKCAD and also something called feature scripts. Feature scripts are basically automated ways of doing things like generating gussets, generating standard tubing, generating a lot of common sorts of shapes, or automating a lot of interesting tasks. But recommendation I have is, and it's well aligned with what we've just seen, is to do some of these things kind of the hard way by sketching first, extruding, getting used to the environment before starting to try to automate things. You need to understand the basics.
Well, that's really great. Thank you very much, AJ and everyone. It was a really great session, and some really great techniques were shown there. Onshape is a pretty approachable CAD package, but it's very powerful as well. As we see there, you're not so long between sketching and putting assemblies together. And hopefully with all the links and the additional resources, you'll be able to support your team to CAD and carefully plan your robot before you build it. If you have additional questions, always happy to answer by phone or by email. And I hope everyone has a wonderful evening. I'm going to just stop the recording at this point here.